Okay, so we'll start the question number 5 discussion. So the question number 5 question says that, so if there are 10 places, so like this one, so we can so on increase this one until the 10th place. So we have to make sure that there are 10 students standing in a row. So you can do that one by imagining 10 places here. In the first place, you can place 10 possibilities there to place one student here. So once you used one student here, the remaining 9 students are there. Therefore, for the second place, 9 possibilities are there. So on, we can move on until here. So once the last one going to be here, so the one here. So therefore, we can find the number of permutation. So number of permutation that 10 students in a row, standing in a row. Okay, students in a row, standing in a row, actually standing in a row. So which going to be you have to realize all the multiplication here. You know that there are 10 possibilities here, so after that 9 possibilities, for the last one 1 possibilities. So therefore the answer going to be 10 factorial. That means 10 factorial. That's the answer for the this first part, where you know the unrestriction here. So this consists, so you know that it consists all the possibilities here. So the question itself says there are 2 students, so 2 particular students. You can't keep them together. You can't allow them, the 2 students always, you know, standing next to each other. You cannot allow that one. That's the question says. So therefore, we will take that those 2 students as XY. So we try to find the number of ways to keep them together. That means always they always remain standing each other, next to each other, standing next to each other. So that's the possibilities. So we are going to find now. So therefore, you know, there are 8 possibilities with these 10. So you are going to consider this as a one number here, because always we are going to move together these 2 students. Therefore the second one here, so the 9th one here. So therefore the number of permutation, when you permutation that the 9 students standing next to each other going to be, you know, that 9 factorial. Okay, 9 factorial. So you know that there are those 2 particular students so can be seated. So the stand can be seated, not seated, standing. Particular 2 students can be standing in 2 ways. So therefore we have to multiply this answer with 2 factorial, because you can interchange these 2. So therefore number of total possibilities there, 9 factorial into 2 factorial. So you know that where we saying that you can start from x to y, like this one you can interchange xy, or you can write it like this one, you can move together both yx. So there are 2 possibilities. That's why we multiply with 2 here. Okay, so now the required permutation, number of permutation going to be, okay, so permutation going to be that 10 factorial, it consists all the possibilities. That means remind together both, and the students not standing next to each other, they are standing separately. That number also there. So if you deduct that 9 factorial into 2 factorial, where those two students are standing next to each other, so therefore you can take it out the 9 factorial out, then 10 minus 2, so the answer going to be 9 factorial into 8. So if you multiply that one, so you get the answer as that you get the answer is a very huge value. Okay, so the 2,703,040. Okay, so this is the answer. Okay, now we'll start to discuss the question number 6. Okay. Question number 6. So which says that there are 8 letters in the equation. They have given a word equation. It consists 8 different letters. So likewise earlier, you can imagine spaces here, 8 spaces. Okay, 5 spaces, because we have to use the 5 letters from those 8 letters. So you have to select 5 letters from that one and rearrange, and you have to find the number of permutation by selecting 5 letters from the 8 letters. That's the question it says. Okay, so therefore, the equation consists 8 letters. So I will the first place, the second place, 3, 4th, 3rd, 4th, 5th. So there are 5 letters we are going to select here. So for the first place, so there are 8 possibilities. You can put E, Q, like that one. There are 8 letters. There are 8 possibilities there. So once you use the 8 letters, so the remaining 7 letters are there. So for example, if you use the E, then you have already used the E, therefore left is 7. So likewise, if you use the Q, then the left is 7 here. So once you use the 1 letter there, the remaining 7, so on, like that one. So the 6 possibilities, once you use the 2 letters here, 6. If you use the 3 letters, it's going to be 5 letters remaining. So altogether 8 letters there. And the final place, you have to select another one, 4. Okay, so therefore the 8 possibilities here. For the first letter, you can 7 possibilities here. So if you select 8 letters from the 5 letters from the 5 letters from the 8 letters, number of permutation, so that can be made, so made by selecting 5 letters, from 8, which is equal to 8 into 7 into, you have to use the principle of multiplication, the fundamental counting principle. You have to multiply, so the numbers here. So if you multiply this value, you can find the value. We always express this one in a way. So we will multiply the remaining numbers, 3, 2, 1, and here also we have to multiply 3, 2, 1. So if you remove these 2, so you can write this as 8 factorial over 3 factorial. So generally we wrote it this way. So you can write it this as in a notational form. 8 letters are there. Permutation, if you select 5 from that one, 8p5, 8 letters from that one, the permutation, number of permutation going to be, so 8p5. So if you simplify this, you got 6,720. Okay, so now we'll discuss the question number 7. It's a simple one. Okay, question number 7. So it says that so there are the 3-digit number we have to produce. So we have to produce 3-digit numbers. by selecting from 6 numbers. So they have given those numbers 6. So therefore you know that for the 3 digits, so it consists 3 spaces. So there are 6 possibilities for the first place to be filled. So in this place we can fill 6 numbers. One of the number you can fill. They have given 6 numbers. Now after that, once you use the one number, the remaining number going to be used in the here in the second place and the third place. So there are the number of permutation, so that can be arranged from 3 numbers, selecting from 6, going to be 6 into 5 into 4. Okay, so usually we write this as a 6p3. So which is equal to, you know that you can write 6 factorial over 6 minus 3 factorial. So in turn, if you simplify, you get 6 into 5 into 4. So this value actually 30, 120. So that's all, 120 numbers there.